KBYP. Let's talk about, while we're on the topic of this myth of grounding for lightning protection. In other words, thinking that grounding is going to make it safe from a lightning discharge, where in fact it turns the antenna into a lightning rod. The same myth and fantasy applies to electrostatic protection. Nothing in electrical code requires or even refers to grounding an antenna system for lightning. It does refer to grounding towers and electrostatic discharge. And the same mistake is made with electrostatic discharge, with the fantasy that grounding takes care of that, when in fact it makes it worse. And the same reason that it makes a grounded antenna into a lightning rod and increases the chance of the antenna being struck by lightning, that's the same mechanism that allows charge transfer up to the top of the antenna, and that charge is static. Static means it's not moving. The early text on this is the branch streamer theory and arc formation, published by Townsend, Townsend. I think it was 1929. It's a must-read. But what happens here is that charges from the ground go up the antenna to the top and shorten the distance and create a potential there, just waiting for a downward streamer to connect with, and that makes a lightning discharge. It is a mistake to try to ground something thinking that will discharge static charges. It can't discharge them when they're coming from the ground. It only makes it worse. We don't see this in amateur radio, but we see it in broadcast. The answer to this problem is a Corona tip, or in broadcast, a Corona hat. It'll actually be some deal like this with a bunch of spikes on it. And you can probably find videos on YouTube where these Corona hats are eroded away, pieces burned off or completely blown apart. What these things do is demonstrated by these different cases that Townsend examined as far as electrostatic potential between oppositely charged conductor pairs, and the different shapes. This one, being two flat plates, is less likely to arc, or it takes more voltage to arc because they're flatter planes. There's less of a voltage gradient. If one becomes a circle or one becomes a point, it becomes much easier. It's also much easier as the distance between the two decreases. Round objects large, round objects small, easier to arc. The easiest to arc is the two sharp points, with, of course, a smaller diameter, and coming down to a very fine needle point makes it easiest to arc. And the reason is that the field lines are much more concentrated, because there's the same voltage potential on each, but that potential is spread way out here, but it's extremely concentrated here, so this arcs over easily. And that is what's happening here. And the discharge path to eliminate static that builds up on an antenna system or a tower is up, not down. This is almost impossible to see in places with relative humidity above about 40%. I have literally seen this. I actually saw the blue corona. I was at the ORV park outside of Richmond, Washington, in the desert in the winter, extremely dry, and under a big, dangerous thunderstorm. And I stopped my vehicle and got out, and I could hear the zzz, the frying sound. I looked at the antenna on the truck, and I could see the blue fingers going off, and I reached over and touched one, and very quickly got back in the truck and left, because I was standing at ground zero for a lightning strike. There in the desert, my ham rig, the Isu, on 20 meters, on the vertical, would have a regular tick, tick, tick about every second, like clockwork. Now, if that charge were coming down, it would have destroyed that sensitive receiver. It isn't going down, it's going up. It doesn't, if it's discharging like that, it doesn't hurt anything. It's not ideal because it screws with the AGC and the S meter, but it doesn't hurt anything because it's being discharged up to the atmosphere. So, want to improve that, put a sharp spike. I didn't have a sharp spike, I just had the top of the 1.25 inch tubing with sharp edges. But it was doing the job. But this is almost impossible to see in places with higher humidity. And in places with higher humidity, it's not needed. If it's happening, you'll hear it, believe me, because that discharge is broadband and you will hear it in the receiver. So there's the science behind static discharge, KBYP.